Hi folks, this is video number 14 on 3D Experience CATIA generative shape design application. The particular item that I'm going to be concentrating on is scaling. Uh, so in fact, there is some limited amount of help available in the online documentation, but I think we need more than that. When you go to a generative shape design, uh, and you select the transform tab, you get your scaling icon, which happen to be part of a group of icons here. And we're looking at scaling in particular. And when you click on it, you get a dialog box that has to be filled. Okay. Now, uh, let me tell you what's happening, first of all, in the nutshell, and then we're going to do example. So if you have a an element, a surface element like that, you have a surface here, and you have a point out there. You have to select the element, which happens to be the surface, and the reference, which happens to be this point. If that is your selection, then what happens is connects that point to every point on the surface and extends it along that line by the factor that you specify. Okay, so this is what's happening when a point is selected as reference. On the other hand, a planar surface can be selected. So here's a planar surface, which you can select as a reference, and you have an element right here, which is your surface. When you select this surface as element and this planar surface as your reference, what it does, it takes the boundaries of this surface that you have here, projects it on that planar surface, and then extends it in the same direction by the factor that you want uh, uh, in the direction that you have. In other words, every point on the surface is extended along the projection direction by a factor that you specify, and you end up with another surface up here. So that's what's really going on. And I'll do several examples to clarify that. Okay. As I've said, some of these icons are also available in part design. For example, scaling is also available in part design. But if you look at the dialog box for it, you can immediately see that not the functionalities are not all the same. Okay, I'm not going to be looking at a part design. I'm going to generate. I'm going to concentrate on GSD, and we move on. Okay. So let's go ahead and our first example is going to be like this. I'm generative shape design, as you can see. So I will select this vertical plane, and on it draw a spline. Dimensions and things like that are totally irrelevant. You're not worried about it. Okay, exit. And then we extrude this thing. We extrude it as a surface like that. Let me also do mirror extend, for example, so you can see it better. Now, notice that here, this extrude happens to be in the part body. Okay? All right? It just happens to be in the part body. Now, let me select, for example, the horizontal plane, and on it, I draw a circle. Don't worry about dimensions. Now I can create a volume, and the volume is, you select the volume tab, and you pad this, and if it happens to be mirror extend like that, otherwise just make it like so. Actually, I did not want this thing to be mirror extend, so yeah, there. Okay, good. So here's the situation. We have the surface that I drew it outside in the part body, and as soon as I try to create a volume, it automatically puts it in order geometrical set. Just be aware of the fact that these volumes are going to automatically place in an order geometrical set. and not going to be placed directly in the body, which is different from part design. Now, let me go ahead and click on select the transform tab, and here's the scaling. Here's the scaling. Press that scaling. All right. Now it says, what is your element? So let's say that let's say I select the surface. What is your reference? Let me select a point, for example, this point, okay, this point, and I make a factor 2, and I say, okay. So what it did, it actually replicated what I explained to you here in that scenario and create another surface. You might say, well, wait a minute. Why did it not do the volume? Well, let me double click on this thing and for the element, try to select the volume. What happens, it won't do the surface. It'll do the volume. Now, if you want both of them to be done, notice that there is in this element selection area, there is this arrow which says multiple selection. So the second time that I picked it, it took the volume. If I want the surface to be included there, I select it, and then I say OK. So both are actually included. All right. So let me do a second example. Okay, so now I'm going to repeat the same problem with a minor difference. So let me first of all get rid of all of these things. And I'm going to get rid of the sketch, which automatically the surface goes with it, and the sketch. All right, so we're back to square one. Now, what I will do is let me go and create my volume, for example. So on this horizontal plane, I will sketch a circle, exit, volume tab, and pad. Good. Now, it puts this volume in the ordered geometric set, right? So this time I'm going to again select another curve, another spline, just like I did before, except that before it did not go into that ordered geometric set because that was not done. That was uh, right here. See this? Now it's in ordered geometric set. Okay. So now we make a surface like that. Okay. And now we're going to do the tab, transform, scaling. Element is this. But if I want to select that guy, let me not select it for now. Ratio 2, and for reference is, for example, this one. Again, it didn't do this. But if you want to add that to it, so you use this arrow, and you select that volume, and then we say, OK. So now they're both there. The moral of the story is that it didn't matter whether that extruded surface was in the part body or in the ordered geometric set. It doesn't matter. All right. Now I'm going to do that when the reference is not actually a point but a line. So I'm going to do cases which deal with this situation. So let's go ahead. Let me delete all of these. I'm going to delete that too. All right. So here's what I'm going to do. For example, on that vertical plane, I will sketch. Once again, my spline, like that. Exit. And I'm going to pad it. Make it a little bit. Okay, that's good. So we have the extruded surface, and I'm going to draw a plane. Now that plane, I can draw it at a tilted angle, there's no problem, but it really doesn't matter what it is. So I will select this plane because I'm kind of lazy. I don't want to draw a tilted plane. So I'm going to use this as my plane, or on that plane, I will sketch a rectangle and turn it into a surface. Okay, there. So the moral of the story is that I have surface and I have a planar region. I have a surface element and I have a planar region. And now I'm going to say, okay, we go to transform, scaling. For element, I select my surface. For the reference, if I select the surface, the normal to it is going to be the direction that is specified here. This is the normal to that, okay? So if I select for this, if I select that, notice what happened in the normal direction, to that plane. It basically uh, multiplied these heights by that ratio. So for example, if I make it, let's say 3, this is what happened. So it took every height, multiplied it by 3 in the normal direction. Okay. By the way, if I make it -1, puts it down here. Keep in mind that what happens is that you have a surface or you have an element. This incidentally could have been, for example, a volume. And you have a planar direction, which planar surface or a plane, which is used as reference. So it projects the surface, the element, into that surface, and in the normal direction, it multiplies it by that ratio. Okay. All right, let me do another example. Let me do another example. Let's get rid of all this. And these two. Okay. So here's the fourth example. So on that vertical plane, I will sketch something like this. Maybe a circle inside of it. Doesn't matter where, doesn't matter what the size is. Exit and extrude it. Let me make it a little bit bigger so you can see what's going on. Make it 100. There. There we are. Okay. Now, I will also make a plane that is tilted. So how do I do that? I go to wireframe, plane, through two lines. For example, through this line, and that line. So notice that the plane at 45 degrees has been created here. You'll see why I'm doing this. Okay, so let's go to the transform. Here's the scaling. Okay. My element is that extruded surface, which has two parts basically. My reference, let me first select, for example, this plane. So that means everything going to be stretched in the normal direction, perpendicular to that surface by a factor of, make it 2. There. Okay. Let me make it actually 5 so that you can see it better. There we are. Okay. So let me remember this bottom one was the reference plane. So this thing is a stretch in the normal direction by a factor of 5. Now, let me put it back to maybe 2. There. Now, what if instead of that reference plane, that reference phase, I use this tilted angle? Look at what happens. There. So when you selected this in the normal direction, it stretched everything by a factor of 2. Get rid of this. Let's try it again. All right, here's the situation. Actually, to make my job easier, let me do the following. On this plane, I will sketch. It's easier to see at least. A plane like that. And fill it. Okay. Now we're going to go to transform, scaling, elements that extrude, and reference is that plane. Obviously, it's going to give you the same answer. Okay. So, okay. All right, keep all sub-elements. That's fine. There we are. Okay. In fact, you can hide some stuff to see what's going on. Let me take the original one and hide it. This is what you've got. Okay, these are the sketches that I can hide also. Hide and hide. There we are. Okay. Now, I mean, when things are not skewed like that, it's easier to see what's going on. When they're skewed, it's kind of messy. But at the end of the day, that's what it is. And have fun.